Hello, I'm Charles Drummond, CEO of SmartULD. I'm here today with Martin Kitching, CEO and founder of our technology partner, Elocate. Martin and the Elocate team have been working closely with SmartULD on the development of SmartULD, a groundbreaking and innovative tracking solution for ULDs that is currently being rolled out with our launch customer, DHL. I've asked Martin to join us today to talk about the development journey we've been on together over the past 2 years and the key challenges in air cargo that SmartULD is designed to solve. Hey, Martin, it's great to have you here in Bangkok. It's a long overdue catch up, and I look forward to discussing SmartULD with you today
Yeah, thank you very much. It's great to finally be here, and it makes a change from being here discussing this and in the airports testing.
and getting your head out of the tracking information, right?
Yes, exactly.
So, Martin, when we look at the current tracking solutions available to the industry, what are some of the limitations and how has that driven the development of SmartULD?
Yeah, so what we understood from the very beginning of the development was that battery was the main problem, battery life. And the fact that most of the devices were limited due to the battery and also then limited to the technology that could be applied. So many were using Bluetooth type technologies because of lower energy consumption, that they could prolong battery life due to not consuming much power, where companies then have avoided the use of cellular technology, satellite technologies, which give global communication without infrastructure, but obviously are more heavy on energy consumption, which means battery life then is limited to 6 to 12 months.
So the current solutions are really constrained in terms of the best communication technology because of battery life.
Yes, they cannot produce enough energy from a single battery to guarantee more than 1 year communication at the levels that we've been testing at with cellular global communications, or with adding communications like NTN satellite communications connecting to people like Starlink and Skylo.
So, what is the solution to addressing this battery constraint?
So the solution is basically kinetics, or uh, harvesting movement. So what we understood, that when we started the development, that solar panels just weren't an option, because within the aviation cargo, it's everything's moving during the night. And unfortunately, there's no sun during the night. So it's not possible to harvest energy from a sun that's not present. So what we looked at, it was the next source of energy that's very evident within the cargo environment, and that's movement. So we've been developing a technology that then can basically harvest the movement of a container by basically simple movement, and harvesting that into usable energy that enables us to basically power things like cellular or satellite communication.
Right. So, in the container tag device, you're moving it before, and it was rattling. That's the energy harvesting at work.
Yes, so without being too descriptive here, then basically to generate energy, you basically just vibrate the device and we're generating energy. So with any movement that the device is subject to, then basically we're transferring basically any sort of vibration or movement into usable energy. So that's either low vibration, which is just engine vibration, up to basically turbulence, to then ground handling vibration, where we're getting significantly more energy due to the level of the vibration. So any sort of level of vibration, then this device is able to take that, convert it into energy, and then power a number of different technologies.
And you've been able to achieve that not only in the container tag, but also in the pallet tag.
Yeah, so within the pallet tag, this has been a lot harder to develop due to the restrictions on space. So we take basically the larger device here, and to put similar technology into basically a device that's almost 10 times less size, and with one of the most awkward shape factors that we've experienced. which doesn't fit a standard battery, that doesn't fit standard technologies, or even the size of the components that's going on that. The limitations we've had on the pallet tag have been immense. So to finally get to a solution where we're able to harvest energy from movement of the pallet in this form factor, we've impressed ourselves.
Oh, it's very impressive. So in this small form factor, you've got energy harvesting, you've got cellular communication, satellite positioning, Wi-Fi multilateration, and BLE capability.
Yes, so within this device, like you said, we've got a multitude of different technologies that are basically evident within the larger device that we've been able to encapsulate into the smaller device, where we're able to do standard 4G communication. With this device, we can also communicate with NB-IoT, which is predominantly used in the US and Europe. So we're able to go on to these additional networks. We're able then to link with satellite communication via NTN. And then we've got the same sort of technology in the device for either GNS global positioning using Wi-Fi or Bluetooth sniffing for additional indoor locations, so we can match accuracy of outdoor location with indoor location by being able to use a multitude of different technologies combined.
Okay, so there's a lot to go through there. So in terms of the satellite positioning capability, these are potentially Starlink ready.
So with satellite communication, so they're already Starlink ready. And with our partnership with our cellular provider, then they're already as well cellular and NTN active. So they've already got the contracts with Starlink that enables us then, with the same package that we've got, to jump between cellular and satellite connectivity with basically the support of our cellular provider.
So the development's really been done with keeping the future opportunities in mind.
Yeah, so one thing we've tried to do is look at what would be happening in the next 5 years and how we would see basically the technology migrating. Because within the technology field, you see with 1 to 2 years how fast technology changes. We've seen how AI, how mobile phones, how everything changes at an enormous speed. So if we develop a technology that's only basically being thought out for the next 1 year, then this is going to be replaced before basically then the device itself is even launched into most of the clients. So we need to future-proof and think what is going to be asked for next, which satellite communication, even replacing standard GNS with the sister GNS. So we're actually able to deal with predictive satellite positioning rather than just dealing with standard satellite positioning. And then you've got the evolutions of energy harvesting, to then how we're taking the information from the device and taking all of that data into advanced analytics and AI.
Okay, Martin, and something that you mentioned earlier was around the ability to position within a building using Wi-Fi sniffing. Can you explain exactly what the Wi-Fi sniffing is? Because my understanding is that we're not connecting to a Wi-Fi network.
We don't need to connect. What we're doing is basically taking the signal strength from each Wi-Fi router that it sniffs and then multilaterating a position. So we're able to say that basically within a warehouse, given that we know either we or a provider like geolocation API provider, we're able to use known Wi-Fi router positions to then multilaterate indoor positioning.
All right. So, Martin, in addition to the energy harvesting and the communication capabilities, what other capabilities does the SmartULD device portfolio have?
So within the portfolio, what we have is with the very basics and the standard that's on all devices, we have then movement, impact. We're able to see rotation, so we're able to use both the accelerometer and gyroscope to gain a lot of useful data that can give MRO stations and others understanding as to impact damage, how basically the ULD or pallet is being used within the supply chain. We then also have then environmental sensors that can give us anything from volatile organics. So we can understand basically what gases are then in the surrounding area of the device. We have hydrogen, CO2, CO sensors, so we're able to detect from early detection of lithium battery to also our standard fires, standard impacts that's happening within the cargo itself. And then we've got other sensors that can be fitted at the request of a client, such as occupancy. So we're able then to see how occupied a container is to make sure that the container itself is then fully loaded, fully utilized, and that basically this is giving the cargo, the integrator, the airline, the best optimization of their cargo, reducing carbon footprints, as basically then the same cargo is basically going within the ULDs with basically less travel. And we then basically able to get more utilization, more load within the aircraft due to the fact that the ULDs themselves are fully occupied.
Okay. And also temperature, humidity, and pressure. So an airline, if they wanted to monitor perishable cargo, then that's a possibility with the container tag.
Yeah, so with regards to perishable, so you've got basically the standard where you can even track pharmaceutical. So you can link with temperature controlled pharmaceutical shipments to then perishable. And with also the data that we've got, similar to what we've done with the lithium battery fires, we're able to detect mold. So basically, there's a number of key data points that would identify that a perishable container is actually subject to mold. So it means that we know that with things from rice shipments to other perishable type goods, that basically early detection of mold can help separate that out and basically protect the rest of the load. So this basically protects a lot of food waste, given that around about 25% of all perishable goods that's basically in cargo as a total is basically going into waste. And this can prevent a significant amount of that by early detection.
Right. So the combination of the various sensors and the devices is gone well beyond just providing geolocation for ULD management. There's a whole lot of insights that the airlines can get from the SmartULD platform and use it to manage things like perishable cargo. And what are some of the other insights that they can get from the data?
Yeah, so I think we're just at the tip of the iceberg at the moment with what's possible, with both what we know that the airlines and what cargo management is requiring, and what we don't know they're requiring, other data that we're able to capture and aggregate and provide them that basically at the moment we're unaware that they've got these problems. So at the moment, with what we do know, that we're able to manage the efficiencies of everything from ground handling and make sure that basically the right thing in an airport is in the right location, that it's managed correctly, that cargo or ground operations in an airport know that they've got the right number of assets in the airport to enable them to perform all of the airport activities, making sure that airplanes are launching, taking off on time, that airplanes are being loaded within the time. And as we see the time windows reducing with a necessity to turn around cargo, turn around passengers, to turn around aircraft more frequently, then the fact that we've got technology that can basically support the activities of that, which is like an example that we're working on at the moment with the load confirmation. So we hear when I'm on a low-cost airline, you hear it frequently, that weight and balance, that basically planes are subject to strict weight and balance rules. And to be honest, you think this is made up. You think this is something that the low-cost airlines are just telling you. So you put your bag under the seat and that everyone's got space for the carry-ons above. And actually, it's not true that the airlines do have strict weight and balance rules that they need to follow. And thanks to the technology we've got, we're able to help the ground handlers to basically make sure that the ULDs are loaded in the correct sequence or in the correct position on the aircraft. Where currently we know a lot of airports struggle with basically loading aircraft, unloading, reloading aircraft. And this is causing flight delays, this is causing huge inefficiencies. And with this solution now, we can ensure that basically aircraft are loaded correct first time, making sure they take off on time, that the cargo is basically in flight, the cargo is not missed, which again is improving not just the efficiencies, the cost, but reducing the overall carbon footprint of the aviation industry.
So there's been a clear progression here from addressing the issues with the battery life to enabling better communication. So we've got better quality data, which then converting into insights to solve these specific airline issues.
Yeah, so we've seen that being able to take this data into the back end and start applying analytics, start aggregating data, we're able to know a lot more of what's happening. So within this, we able to create now what we're classing as a fingerprint map of the cargo. So we know that it's landed, we know that it's traveling from X to Y, we know the time it takes to travel, we know basically what's happening within the full supply chain. And these are insights that basically normally just experts know, but something that's not normally within a digital infrastructure that's applying and providing basically users with critical information, knowing exactly where things are, when they should be there, and being able to predict when they should be there.
And it's more than just using the data from the SmartULD devices, right? We're also able to bring in other data sources and then use machine learning and AI to develop predictive models and further insights.
Yeah, exactly. And one example of this is the fingerprint tool that we've developed, where we started by using integrating basically the full Google geolocation API. So taking basically all of their known Wi-Fi addresses along with their geolocation, cellular cell tower location with combined with their global satellite. So we've been able to start taking all of that data in. We then now applying advanced AI and machine learning, where we're able to create this unique fingerprint where actually the devices need less connection now to produce the same accuracy. And we're able then to evolve this into more than just the devices that we've got at the moment with the pallet tag and the container tag. We're able to take this into now a lot smaller tags, take this into a lot more different applications within the aviation industry that resolves even more problems. So we see this as something that is like a snowball that's just gaining more opportunities
And
the
the
more
one
it's rolling down the hill.
application that we haven't gone into a lot of detail, which is very exciting, is around addressing the risk in the industry around lithium battery fires. Do you want to talk about what you've developed in terms of the sensor technology and also the algorithms?
Yeah, so one of the issues that we came across when we started to develop this was a huge risk with the fires. And thanks to the partnerships that we've had and with the unique FRC that Avios ULD is producing, then we looked at how we could basically further add to the what that basically FRC is providing and how we could give that early warning to basically prevent the fire, not just to contain the fire. So we looked at what we could do, and we've done many various tests in big test sites in France where we've basically blown up ULDs to understand basically how we could detect that key 1 to 2 hours before a fire starts. But when the battery itself is going into that critical thermal runaway, when it's damaged. So what we've discovered is the types of gases that basically off-gassed at the very early offset of lithium thermal runaway, and we've been able to apply that into the device as far as sensors, but that's not enough. So what we've also found that being alongside an aircraft, that similar hydrogens are present within a battery fire and within standard aircraft refueling. So it's not enough just to take the sensors. What we've had to do is build unique algorithms that's able to use different data sets to identify the difference between aircraft refueling and the off-gassing within
to mitigate
a
the
lithium battery.
potential of false positive readings.
Yes, on the same as you want to make sure that no batteries at risk of going onto an aircraft. The other thing, what you don't want is cargo basically sat on a runway waiting to go onto an aircraft or missing an aircraft. So we've got to basically have something that enables a very accurate reading. So when this communicates that there's off-gassing and there's thermal runaway in occurrence, that this is actually real. That if it's not real, then this can cause more disruption than
Absolutely, and
effectively the
I
safety
believe you've
impact.
recently had a personal experience with a lithium battery incident
Yes.
holding up your flight.
Yes, so I was on a flight from Paris to Prague about 6 weeks ago, and we set off on the flight, and you could smell that, basically a smell that obviously with 1 year of testing with this lithium battery, you knew what the smell was. So I'm there and I'm thinking, yeah, do I warn somebody? Do I go into the bin myself to shake the device because I've got it with me at all times? So what do I do? And actually the air stewardess was actually starting to open bins, which was quite strange. So the pilot had said that, look, we're having to divert into a parking situation, and then the air stewardess continued to sniff, which created a lot of concern with everybody on the flight, and for myself was bit of disbelief that basically you've got an air stewardess basically sniffing every cabin bin to understand where the lithium battery off-gassing is occurring and whether that's resulting in smoke or fire, if that's basically a safe position for a flight to take. And we're sat there for 30 minutes effectively
So
waiting
the
then
fire
for the
tag's a
smell
bit
to
more
go away.
reliable than a cabin crew nose.
So yes, compared to basically an air stewardess sniffing to advanced sniffing and algorithms in a device, then this could have, with this technology in, let's say, a cabin bin, this could have prevented a 45-minute delay and basically made sure that the battery that was definitely off-gassing was basically put into basically a cabin pocket, fire pocket that you have on standard flights now, that's basically safe, and the flight then can continue. Because to be honest, knowing that basically that was a lithium battery fire and knowing what was occurring, I was quite nervous on the flight that basically it's taking off, and yeah, I know the damage that just one battery can create with going into a thermal runaway, and
Right, so
what that can create on an
the
aircraft.
applications beyond ULD for this technology.
Yes, I mean for the airports, you just walk through an airport now, and knowing then through the tests we've done what the potential creation of a lithium battery is, fire can be, and we found this to be impact. That basically you've got a laptop in your bag and you drop your bag, then there's a high likelihood that that battery now is going into thermal runaway due to the impact. And if the device itself, if your laptop does not have a very secure battery management system, or even with a very secure battery management system, there's still a high likelihood that that laptop now is going to go into thermal runaway. With things like vapes, which is the number one issue with lithium battery fires on any flight worldwide. And this is due to the lack of battery management system that's on the batteries within a vape. And then this is critical situation where you drop something, your bag, you drop something going through security. You've got many instances where during basically leaving home to effectively arriving at your destination, where any time you could basically drop, or let's say you see how luggage is handled basically through the flight, and how this is basically can be handled good and bad depending on location. There's many instances where the battery can basically go into a thermal runaway situation. So if you were able to detect it both in the cabin bin, but also basically before entering the plane, things like security control or even check-in, all of these extra steps could be applied to give you extra levels of security and extra identification of lithium battery fires
Yeah, it's a
before
very
they ever occur.
important development, and it's critical for the industry that we've moved beyond just having containment solutions to having these early detection warning.
Yeah, and we discovered this when we actually were applying for the patents on this. So when we were applying for the global patents to basically protect the technology that we've developed, we saw that a lot of let's say the competition is more focused on basically protecting Teslas and making sure there's the technology that's preventing cars going into thermal runaway due to battery fires. And a lot of the focus is there, but what we see with everything from basically normal day life for consumer charging, basically anything from e-bikes, the likelihood of a lithium battery fire is increasing globally in most applications. So yes, this technology is something that is fresh, patented, and something that I think has hundreds of
Very
different
exciting.
applications everywhere.
So, Martin, going back
Yes, very
to
much.
the earlier question where you touched on the limitations of the some of the current solutions available to airlines, uh, the one benefit with SmartULD is that you don't need the infrastructure rollout, so saving cost and time for implementation. But the SmartULD devices actually become the infrastructure, and so in terms of this ecosystem that we're creating, it opens a world of opportunities for connecting different sorts of aviation assets and even potentially some consumables that an airline may want to track.
Exactly. We see that with what we've tested so far and actually ran a significant amount of let's say, proof of concept testing on basically the full networking. The first thing is us having that network is that unique infrastructure-free network, which basically many devices are limited with, means that their devices are reliant on its own infrastructure. With the technology we've had and trials we've been doing over the last 6 months, this device basically can become its own effectively gateway on wheels, that any device that's communicating with BLE, with Wi-Fi, with any other communication can basically link with this device
So
and use
right
this
now, this
device as a
device
gateway.
here is communicating with the pallet tag.
Yeah, so basically this device, um, as it moves and as it stops, it's basically this device, this pallet tag, is basically communicating its information. This knows that that pallet tag's there. This is able to enhance then even the location of this pallet tag using the greater technology that basically is available in the device. So you could take a very basic basic BLE tag for something like a net, a cover, any other basically, let's say, normally not tracked components within the aviation, and you're able to communicate to this device, providing exact locations of every single bit of assets that
Right.
you've
So
got
you and
within
I
this
sitting here with
ecosystem.
our mobile phones, it's potentially detecting that, and also the Wi-Fi router here in the studio.
Yeah, so we detecting the Wi-Fi routers, hotspots with the phones. Um, there's even a number of devices in my bag that it's tracking at the moment. So basically we're able to basically detect anything we need and also apply filtering. So one provider asked us to be able to detect basically hundreds to thousands of different BLE devices that's not within basically the current infrastructure, and basically then ignore all of the other BLE devices around it and just focus on that BLE communication with those tags on those pieces of equipment. So we're able to filter out and to home in to say exactly that's the tech it wants to connect to, that's the asset that the client wants to track, and then that's all what
And
the
the
device is
device
set
can
to
pick
track.
up some of the other solution providers' equipment, which is currently rolled out in the market.
Yeah, so we've tested that as well with these providers and with the consent of these providers, and basically being able to detect their technology. So with a normal infrastructure that a lot of the providers, they have, let's say 150 of basically over 8,000 airports worldwide that they've got infrastructure in. So basically for all of the other airports, people are looking then at the aviSULD, SmartULD tag to effectively act as that infrastructure to enable the tracking of their technology outside of these 150 airports. So making basically their technology more connected globally, thanks to the fact that we
And
have
it
this
provides
gateway
a
on
huge
wheels.
opportunity for detecting everywhere a device may travel, without the need for having the infrastructure installed at those different points.
Yes, I mean, we just done a recent trial in both in China. We've done recent trials where uh, a well-known uh, integrator has basically been shipping and doing tests within China, and we've been able to actually accurately locate basically pallet, other types of BLE devices, along with this device accurately within China, which is normally very restrictive due to the fact that basically Google doesn't work properly in China, that your normal basically mapping technologies aren't available basically globally. So what we've been able to do is not just with the technology, but again, with the unique algorithms and machine learning we've been able to build into the back end, we're able to distinguish where the devices are globally, being able to find the best solution to be able to locate it automatically. So be able to switch to different types of geo mapping solutions to give exactly the location that the device has within any country globally. So there's maybe few that we haven't visited, but we can guarantee
Okay, and
this
that's really
location in
been the
most countries.
focus of the past year, is doing these field tests. The project's been running for a little over 2 years now, with Elocate and aviSULD. Last March, we launched the first versions of the SmartULD device to the industry at WCS, and that was really a turning point in the direction we took. Do you want to elaborate a bit on what happened at WCS and how the direction of the development changed after that point?
Yeah, so when we first launched this, obviously the battery, that's clear that basically we needed to find a solution. And that's where we started to look on the fact that shipping during night, we needed kinetic, not solar. So we knew we were focused on the right energy harvesting source. But at that time, we were looking at that energy harvesting source to power Bluetooth or LoRaWAN. So more, let's say, less heavy energy consuming technologies, but with infrastructure. So we also developed what sort of infrastructure technology we would have. We developed different types of fixed gateways, fixed infrastructure. And then we approached basically the Hong Kong Expo, and there we met the launch partner, DHL, and we had an excellent 3-hour conversation.
And
nor us.
they've got a long history of testing the different tracking solutions, right? So they were able to give a lot of insight as to what worked, what didn't work, and what they wanted.
Well, for the insight we got at that first meeting, something we still talk about now as being paramount to the full development. What they were able to provide us and the challenge they set, that to basically not have an infrastructure, to go away completely from infrastructure and have a technology that could be basically communicating through global 4G and satellite communications. But then having the power source to be able to power that and to keep the battery life. So basically, this becomes a mobile gateway that's basically on steroids. Then this device was basically the challenge back then. And to be honest, I would say that the teams at DHL have been absolutely paramount in what we've developed here. Their support through the full development cycle, helping test, helping advise us in what exactly is required within the industry has been paramount in the development. This has been something that would have took much more time if not for their insights and their support.
Absolutely. It's a customer-led development. And this tailored approach to coming up with a solution is what's now also been discussed with various airline customers, for really understanding what they want to achieve out of the technology, and then what we're delivering with the devices and also the platform.
Yeah, so with the various different customers that we're currently talking to, they've all got specific pain points, different areas that they want to address. Or we've not seen basically a cut and paste scenario where everyone wants the same. Some are small tweaks, some are major tweaks, some are different detections, some are different problems that they're facing within basically their own ecosystem. So being able to have something that we can build on and basically just do tweak this, customize it for the various different clients is something that's providing clients with something that's actually tailored to solve their problems, rather than us selling a technology that basically is selling a Ferrari when you're only going to a local shop.
And I think that creates a lot of value for our airline customers, is really understanding what problem they're trying to solve and then using what's been achieved through SmartULD to meet those needs.
Yeah, it's being able to take what we've got with regards to the data, aggregate that data, and then also apply the level of analytics and the new AI that we're developing within the platform. Um, we're able to tailor this to provide airlines with data they need now to solve problems they need now. But as we're brainstorming with them, we're seeing that we can actually solve more of their problems, that there's actually a lot more under the surface than just the normal tracking, the normal location that they need to fix. And this is basically like taking kids into a candy shop. We're taking them basically through the journey of what we can actually do, and the input from the various different customers, what they want to apply, what problems they want to solve. It's basically something that, as we together were at one airline, they were, wow, this technology, we didn't even think this existed, that we thought that RFID was basically the forefront of technology. And then when we told them what can do, they were just basically piling on. Can we check this? Can we check this? Can we check this? And this is the benefit of the technology.
And having a tailored solution approach. So we're not trying to push an off-the-shelf solution.
Exactly. We're not saying that this is something that we're trying to get you to change to meet the technology. We're able to change the technology to provide the client with exactly what they want at basically the level they want it.
All right. Well, great catch up, Martin. Thank you for providing all that information and the insights as to where we're at and also what the future looks like. And I look forward to ramping up the rollout and seeing where this takes us.
Yeah, same here. It's a big ramp up we're now doing. It's a good rollout, and it's brilliant to finally have this technology ramping up in the market, and this is motivating everyone that's involved, that's went through this 2-year journey in basically getting this technology to where we've got it today. So I appreciate Avios ULD's support in choosing us and working with us to develop this technology, and obviously thank DHL for also persevering with us and helping us to develop it. So great to be here, and thanks again for working together on creating something that's unique within the market.
No, agreed. It's been a terrific partnership. So thank you, Martin.
Yep, thank you very much.